We're going to talk really briefly about project management. And so what I really want to present or have you think about in project management is the motivation, why we use project management skills, why it's important. We're going to have an exercise, and you're actually going to be using this for your project. In other words, you're going to create a work breakdown structure, which we'll cover in a few minutes, for you to help organize your designs and thoughts and your process. So a project from Wikipedia. Remember, we looked at system before. So now project, and Wikipedia is the end-all definition of everything, isn't it? Temporary and one-time endeavor undertaken to create a unique product or service. And the important thing I point up there is a project is temporary. So let's ask a question with respect to the thing that you're going to do for this class, what I call a project, right? Is it temporary? Are you going to do it again and again and again? No, you're going to do it once, right? A process is something that you do continually. So what would be a good example of a process? That might be everyday manufacturing this product that you design. So the manufacturing aspect of it would be a process. Running a McDonald's each day is a process. All right, so we're distinguishing this because we're going to look at a project as a temporary endeavor that a project manager, or the project management process for this, is going to be this discipline of organizing and managing resources. So remember systems engineering the other day? We talked about design, processes, technical aspect. So the project manager is the one who's worried about resources. People, money, time. Time would be, in this case, a schedule. And by the way, a project is typically managed or is identified by the scope, what it does, how much time it takes, and the cost constraints. Cost will be associated with people too, all right? So when you do projects, one of the first challenges is that it's delivered within the constraints. And so we've already talked about some constraints associated with this project that you're going to be doing. And this project that you're going to be doing is associated with a consumer product. I don't want to go too much into it. But, you know, I've already given you some constraints, right? So why? Well, think about this. No matter what you think, you're not going to be writing code, designing hardware for your entire life. In fact, typically, engineers who graduate, especially with master's degrees, graduate or are promoted up into management within 5 years or less, all right? So you need to understand how projects work, and keep in mind, you are also working in a project even when you start at a company. And so you need to have an understanding of how projects run in your work environment before you actually start in the work environment. So we, in the world of project management, have created what we call a body of knowledge. In other words, some hints on the best way to run a project. Now, the body of knowledge is a book that is approximately this thick. There is no way you're going to be able to understand all of that. So I'm going to just cover a couple of good hints. In other words, some tools that you could use that will help you. By the way, when you're running a project, you have 5 different parts of it. Number 1 is the initiating. So, have you been initiated for your project? I've pretty much given you the charter of what you have to do, right? Formed you into a team. Next would be the planning. So, in the next week, you're going to plan your project. You're going to figure out all the different parts that you have to create. The next part is executing. Once you are executing your plan, in other words, you're going to be doing a hardware design. That's part of working in a project. The whole time, you're going to monitor it to say, I said I would be done with the hardware design by this day. How close am I? If you're not, well, you're monitoring and controlling your progress. You would then adjust your planning and executing to meet the deadlines that you have to do. And then finally, closing is going to be the very last day of class, the final, where you turn over all your materials and declare that you're a winner. So let's take a look at some basics. So remember these tools I talked about? Well, I've mentioned in systems engineering work breakdown structure, right? Is a neat way to organize. We're going to go into that. Project planning, well, you're going to have to identify who's going to do the tasks and how long they will take. So not only do you have to identify what tasks have to be done, you have to identify who's going to do them. You're going to have to say how long will they take to do. You have to make sure that who's going to follow up on this plan. And then, oh, by the way, am I going to make you change requirements as we go along? So at this point, I may make some requirements later. For example, I may test out some new technology where I say, you must use this new technology. You know, maybe I actually find electric paper or electronic paper, right? And I get a deal where they say, here, this 2-inch by 3-inch device is 50 cents, and I say, this is just so good. You guys, I'm not going to make you, fight for LCDs and all this other stuff here. Here is electronic paper, use this, all right? Who knows, I may say that later. I don't know. So a simple work breakdown structure is all you need to do, and I'm not even going to give you the format for this. Here's a suggestion. So you list all of the things you have to do, and how many hours you expect it to take, and who's responsible for that. Now I add a couple columns over there. That's A, B, C, D. That's person A, B, C, D, right? How many people do you have in your team? 4, 3 or 4, right? And so you identify, like, who's going to work on the work breakdown structure? All of you? Who's going to type it up? Who's going to submit it? Now, there are other things that you have to do as you go along in your project. So in your work breakdown structure, you try and identify as many individual tasks that must be done for the entire project. Now, within reason, all right? Because you don't want to say, and this task is going to take 10 minutes, and this task is going to take 5 minutes. You want to have some sort of border on how long something's going to take, right? So you may say, create work breakdown structure is going to take 2 man-hours. In other words, half an hour for everybody sitting around to figure it out. And so you just say A, B, C, D, 2 man-hours, but it's half an hour each. And I say use a spreadsheet because it makes life really easy. By the way, typically for as many tasks that need to be done can be driven by the actual deliverables associated with this project. Do you know what the deliverables are for this project? Have you seen this? So, this says project deliverable. Requirements and project plan. So what do you think you have to turn in next Tuesday? A single document that shows what your requirements for the project will be and the project plan. I suspect this will be 3 pages. Right? Oh, here's another one. Initial hardware block diagram, including processor selection. That's another deliverable. What are you going to do to make that deliverable? Initial or final block diagram, schematic, bill of materials, purchase orders, layout and Gerbers, manufactured boards, et cetera, et cetera, et cetera. All right? These are all deliverables that you will have to do. One of the other things, I was thinking about another thing to make a deliverable in here. Oh, it was the cost of the device in quantities of 10,000, broken out by all the bill of materials and manufacturing cost. So I think I'll have that due like maybe this day right here. You know, I was thinking about making you do a 3D printed device, but I think we've got so much going on already that may not be possible. So just for fun, you should be on the lookout for a case that you might be able to put all this in. You know, an off-the-shelf, already built box or something like that. All right, so as we said, estimate the time needed for each task, group the tasks by precedence. Does something have to be done before something else? By the way, we often also use a Gantt chart. This is like a waterfall. So this task has to be done, and then sometimes you say, okay, and when you're working on this has to be done before you can start that. And by the way, you know, this, you have to be halfway done before you start that, et cetera, et cetera, et cetera. You know, here's another example of this has to be done before you start that. But that's not always the case. Here's an example of a Gantt chart, one example. All right? So, I'm not even going to talk about risk. So the simple exercise, you're going to be planning your project work. You're going to be doing a work breakdown structure. You know, who does these tasks? How much time will it take? Identify the deadline of those tasks. And are any have to be done before the another one could be started. So a good example will be before you can actually do the hardware block diagram, you have to decide what processor you're going to use, right? That's obviously, you have to decide the processor before you do the hardware block diagram. You may need to do some additional investigation in parts and devices. That's why I want to get in your hands some XB devices, and I've got another device called Particle, which is a Wi-Fi chip. It's $19, but in bigger quantity, it's even cheaper. So I want to see if I can get that in your hands first, so you can see what's going on. So that is your main assignment for the next week. You can use pretty much any resources that you could think of out there. I'll try and post a couple of more readings and resources out there that might be helpful for you as well. Any questions before we finish up? Yes, sir.
How are you planning to buy components, the PCB and component assembly?
Okay, so how am I planning on buying components? You're going to be creating a purchase order in a couple of weeks, and you will specify exactly what you want to buy and where you want to buy it from. That'll be the subject of a future class discussion. And I'm going to pull all these together, and I'm going to order them all at the same time, and stuff will come in, and then we'll just, here's your purchase order. You wanted this part, this part, this part, this part, and this part. Now, it'll happen later that you say, I didn't do this right. I need another replacement. I burned it out. So then you'll have to submit another PO for that.
The PCB and the assembly parts?
The printed circuit board, we're actually going to mill here in the department. So we have a device that will actually take an epoxy board that's coated with copper, and it will actually grind away, mill away the copper to make traces and stuff.
As for the assembly of the ICs, it will have quite a narrow pitch, so manually it will be.
You will have to do that manually, yes. Now, Eddie is very, very good at fine pitch soldering. And we have some really good tools that are not in the labs that you have access to. So we'll make things more available for you that are finer pitch. But something to be said is never underestimate the ability to use solder paste and flux for soldering. We do this all the time. And we may actually do solder masks. We may create solder masks. We'll have you wipe solder paste across the board, place the parts, put it in an easy bake oven. Oh, you guys don't know what an easy bake oven is, do you? A small toaster oven. And basically solder parts like that. Or I might even get our wonderful buddies that do board manufacturing to actually do something for us. So it's something I have to look at. All right, that's